Software libraries can be configured in SUSE Linux as well. In order to really work with libraries, though, we have to understand what a shared library is, the kind of differences between static and dynamic libraries, as well as how to configure those libraries to be in effect on a Linux box. So let's talk about shared libraries first. Libraries are an easy way or an easier way to allow written code to be reused, which results in smaller programs as that code doesn't always have to be included with them. It can come from a different source and exist on a machine and be used by multiple programs instead. Now, these pieces of code are in what are called shared libraries. Now, to use them, you link to them either in your code when you build them or when you run the program. So you can use both methods. Now, libraries are stored by default in the /lib directory or the /lib64 directory, depending on whether they are 32 or 64-bit binaries or libraries. Some examples. If we looked under the /lib directory, we can see that there is a library out there, an ELF file. It's 32-bit. It tells us information about it and the way that it was built and so forth. We can also see under the lib64 directory, there is a similar file, but it's built specifically for 64-bit, so we can see those differences between them. So what is the difference between a static and a dynamic library? Well, Linux systems have two different executable programs. We have statically linked and we have dynamically linked. Statically linked executables contain all of the functions that they need inside of their binary. They are complete programs and they don't go external in order to get any information or to borrow any code from anyone else. Now, the advantage of that is that the programs will likely work without the need of you installing any additional libraries or packages elsewhere. They're designed simply to be self-contained. Now, that can be attractive, but it's not always efficient. And dynamically linked executables result in smaller programs. They require the functions from external libraries to run, which is a dependency, but dynamic linking permits a package to specify which libraries are needed in order for that particular package or executable to run. And many programs can share a single copy of the library instead of loading the memory with a whole bunch of different copies of the exact same code. Obviously, better if we can reduce that. So, when working with dynamic dependencies or libraries, we have to use a tool called LDD. Now, this is a tool that allows you to see where various libraries are going to require other, or various executables will need various libraries and where they are. So if the primary doesn't use a library and you use the LDD command, it tells you something like in the bottom box there, not a dynamic executable. Now, the output of LDD can be explained. With just a little bit of work, you can see how these things work out. LDD space LN. What does that give you? That's the Linux version of here are the shared libraries that we're using. Now, if we go and look at one of those, that's the next box down, libc.so.6. What is that? Well, that's pointing somewhere else. That gives us information about something else. Okay, and where is that? Well, we track it down. We can see where all of these are going. We can see how they're related to each other and so forth. So LDD by itself, useful, especially when doing debugging and looking for information about why a particular program won't run or is having troubles running on an individual system. So how do we configure libraries? Libraries are generally affected, dynamic libraries are affected by two different configuration files. There's in the etc directory an ld.so.conf and an etc ld.so.cache. If you go and take a look at that first file, you'll see something like, here's the location of the libraries, here's some information or some places that you should additionally scan, in this case, include file that we want to use as part of our configuration. Now, that .conf file tells us where those things are located, but there's also what's called the dynamic library cache. When we load a program, one of the things that developers and a lot of times consumers of a program are interested in is how fast does a program load. Now, there is a tool called the ldconfig command that processes the information in the ld.so.conf file, that configuration file we just looked at, and it creates the necessary links and pieces that are needed in the ld.so.cache file. This cache file makes it so that the load times can be faster because it is, as the word implies, cached and ready to be consumed. We can see what's inside the cache at any time with an ldconfig -p. And if you change anything inside of the ld.so.conf file, you need to run ldconfig again as root to make sure that the cache gets rebuilt as well. And this should be consistent logically if you think about it. So, what if we want to load a particular library? If we're going to run from let's say a different location than the standard one, you need to go and grab that. There are tools that can grab libraries from those locations. And you can do that by setting a path variable to specify a search path for executables. Specifically, ld_library_path is a colon separated list of directories that should be looked through when going for or looking to include shared libraries that may not be in the default path.